வெந்தது இருக்கா?
Ma'am, am I audible?
Yes, ma'am. Yes, ma'am. Audible, ma'am.
Yes. I think my camera's got some issue. It's showing some information. Can't find your camera. அந்த மாதிரி காமிக்குது. It's okay, ma'am. Let me share the slide. Let me see like whether I'm able to share the slide. Let me check it once.
Okay, ma'am.
Yeah.
என்ன மேடம்? அப்படியா மேடம்? சரி, டைம் டேபிள் எதுவும் சேஞ்ச் பண்ணிடலாம் என்ன? அதை ஒன்றும் நீங்கள் சொல்லலையே. அதை எனக்கு நீங்கள் சொல்லணும்ல. அப்டேட் பண்ணிடுறேன் மேடம். இல்லை மேம், சும்மா நீங்கள் கையில் கிடைக்கிறதா.
Is it visible, ma'am?
Yes, ma'am. It is visible, ma'am.
Okay. Thank you, ma'am. Thank you.
Thank you.
Nirai ma'am is not there. Ma'am, Nirai ma'am is there? Hi, Nirai. Nirai, என்னோட வாய்ஸ் கேக்குதா? Nirai. Nirai, audible? Niraimati.
Ma'am, your voice is audible.
Thank you, ma. Thank you.
Ma'am?
Yes, ma'am. Yes, ma'am. Yes, ma'am. Did you call me?
ஷாமாக்கா கேக்குதா?
கேக்குதுமா, கேக்குது.
ஓகே ஓகே. அதான் இல்ல இல்ல ஆன்ல தான் லேப்டாப்ல இப்ப
Ma'am, shall we start, ma'am?
Start, yes,
Okay, ma'am.
Yes, ma'am. Yes, we can start.
Okay, ma'am. A pleasant morning to everyone. Today we are gathered here for a seminar in the title of Power Electronics for Renewable Energy Systems. Power electronics field is critical for every electrical engineer. So many research has gone, and will go also. In the technologically developing world, we should be aware of recent techniques and trends. This seminar definitely makes you skillful on power electronics. Let's start our program. Welcoming is our culture. Sunshine is a welcome thing. It brings a lot of brightness. I would like to call our HOD, Dr. R. Nirimati ma'am, to welcome the gathering. Please, ma'am.
Yes, Radha. Good morning, one and all present here. On behalf of our EEE department, I would like to thank our management and principal for giving support to conduct this kind of program. Really, it is needful to students to be aware of latest technology. I would like to welcome our chief guest, Dr. B. Chamundiswari, Associate Professor, Department of Engineering at St. Joseph College of Engineering, Chennai. Personally, I know her knowledge on power electronics. She is right person to deal with this topic. Welcome, ma'am.
Thank you,
Our
ma'am.
principal said, I welcome all HODs from various departments. Welcome, sir. I extend my welcome to all faculties. Welcome you all. Last but not least, I would like to welcome my students who are eagerly waiting to get skills on this. Welcome you all. Thank you.
Thank you, ma'am. Now it's time to start our session. I would like to hand over the session to our beloved chief guest, Dr. V. Chamundiswari, Associate Professor in EEE Department of St. Joseph College of Engineering, Chennai. She completed her UG in Control and Instrumentation in SOT Madurai, then her PG in Power Electronics in University Chennai, completed her doctorate in Power Electronics. She has more than 20 years of experience in teaching, done lots of research, published so many papers. She published nearly 10 books and chapters also. Really, we are so lucky to have such an eminent person to give a lecture here. Please, ma'am, please carry over your session, ma'am. Students, please be patient. Ma'am will join you soon. Due to some technical issues, ma'am has left. Please be patient. She will join you soon. Ma'am?
Yes, yes, ma'am. There was a network issue here. I'm very
Ma'am,
sorry.
hope some network issues there.
Now, am I audible? Can I start with?
Yes, ma'am. Yes, ma'am. You
Yeah.
are audible, ma'am.
Thank you, ma'am. Thanks a lot. Yeah.
Okay, ma'am. Thank you, ma'am. Please
Yeah.
carry over your session.
Thank you. Surely, surely. Good morning to all. Very happy to see the gathering here. Very happy and today's presentation it is going to be on power electronics and renewable energy system. That should be definitely effective. Will be useful. And with that, before getting to the session, a thank note should be definitely given without which the session will not go active. I should definitely thank my management for giving me this opportunity to present the topic on power electronics for renewable energy systems. I should thank my principal and the deans and also my heads of the department and my fellow colleagues who have been so supportive. And a special thanks to your HOD ma'am, definitely to your principal sir, your HOD ma'am, and your dear staffs who have made this event also a successful one by starting a very good inaugurative speech. So with this welcome note, I'll definitely start my session with no further delay. And I hope I'm audible.
Yes, ma'am. You are audible.
Yes, yes. Thank you, ma'am. Thanks a lot. Let me present the slideshow. Is my presentation visible, ma'am?
Yes, ma'am.
Yes. Good morning to one and all present here. So today's concept is going to be power electronics for renewable energy systems. I'm Dr. Chamundeshwari from the Department of EEE from St. Joseph's College of Engineering, Chennai. Now, before getting into the topic, let me tell today's agenda. The first and foremost thing, when we talk about power electronics for renewable energy systems, we have to definitely know what is renewable energy systems, why we have to go for renewable energy systems, and what are the different sources available with respect to renewable energy, and why power electronics. Why power electronics has to be chosen, and the field of power electronics, how it is helping for renewable energy systems. So how a power electronic interface will help a renewable system, and what applications we have as far as power electronics is. So today points. Actually, it's a very big area, very big area, and we are going to have only a period of 1 hour. 1 hour will not be enough to showcase all the applications of renewable energy systems. We have to definitely go deep into it. For that, we need a lot of time because it is a very vast area. But still, I feel that I may give an insight or focus into the effect of power electronics in renewable sectors. So you will have an overview idea about this concept. I hope I'm audible. If my voice is that, kindly let me know. So it'll be useful for me.
Okay.
Yeah. Uh, is it? Do you you feel that the voice is very audible or the tone is okay? You want some more?
No, ma'am, your voice is okay.
Yeah, yeah.
No, ma'am,
Okay.
is it okay, ma'am? It is okay.
Okay, okay. Thank you, ma'am. Thanks a lot. Yes. So I told you like we have to know like first what is renewable energy systems. Only when we know what is renewable energy systems, then only we can step into the concept of power electronics for renewable energy systems. That's why I included the first agenda to be what is renewable energy system. We'll like what is renewable energy system. It's all a familiar word. You all know that. We have to know like why the world is moved in a greater way towards this sector. We have a lot of non-renewable energy sources that here. Even the statistical analysis tells that our power sector is stepping into renewable energy source. The foremost reason to know that is very important. And key points to look what systems. We all know that same if it is renewable, it can be replenished or it can be again and again renewed, and it is a natural source of energy. It is a natural source of energy. You all know that, and again we can retrieve it. We can get it from the environment. That is why it is called renewable energy. And all we have been learning that. All we have been learning like what is renewable energy and what is a hot area in renewable part now. And what the power sector, how the power sector concentrates on renewable energy systems. That is why they've given the word like it is derived from natural sources that are replenished rate than they consume. So generate more than that rate to again consume it again. We are able to get it again. How much ever we consume, that much ever we are able to get it back. Not even equal, more than the consumption we are able to get it. That is the important advantage of your renewable energy sources. So some of the important sources of renewable energy, we all know that we daily come across that the photovoltaic source, the sunlight, natural source of energy, which the PV systems. That is why they classified the PV systems as photovoltaic system. That is the solar system as the sunlight's energy is divided into two systems. One is the photovoltaic, another one is your thermal systems. So the heat can also be used, it can also be used. That is major advantage. That is one thing. And renewable so again, there is no uh, that will not become extinct. Never ever the solar source will become extinct. So not the solar source, even the wind energy, geothermal energy, hydro energy, the tidal energy, all comes under renewable. Now can you see?
And still it's in first slide, ma'am.
But for me, it is moving.
Wait a second. Yeah, now it's moving, ma'am.
Now it's moving. Yeah. Okay.
Yeah.
So in the beginning, you didn't see the agenda actually. You were not able to see the agenda.
Yes, ma'am. Yes, ma'am. Now only we can see it, ma'am.
Now,
Yes, ma'am. Yes, ma'am. Now it's okay, ma'am. We can see the agenda slide, ma'am.
yeah. And then I'll start with. Let me tell because I have. Yeah. Thank you, ma. Now it is moving. Just see.
And now we couldn't see it, ma'am.
Ma'am, now is it moving?
No, ma'am.
Ma'am?
We couldn't see the presentation slide, ma'am. Yes, ma'am. Now it shows me.
Well, is it moving? Now I'm moving it actually. Can you see that? It shows it. Yeah. Thank you. Thank you, ma.
No, ma'am.
So
It's in
agenda, I
second
was
slide
telling
only,
like
ma'am.
first we're going to see what is now it is in second only because now it is in third slide. What is renewable energy systems? Can you see that?
No, ma'am. We can see
Can
only
you
second
see?
slide, ma'am. Agenda of presentation.
Any network issue from your side? It is moving.
Let me check, ma'am.
My net is connected also.
No, ma'am. Here, ma'am. Here, no one can see it, ma'am. It's in second slide only, ma'am.
Now I'm on agenda only. Now can you see the third? What is renewable energy systems?
Yes, ma'am. Yes, ma'am. Now it's in third, ma'am. What's renewable energy systems?
Yes. I don't understand why it is not moving. 1 second.
Okay, ma'am.
Ma'am, should I rejoin?
Ma'am, now it's visible, ma'am. It's in fourth slide, right?
Yeah. Yes, it is in fourth slide. Can you see?
Sorry. Yes, ma'am. It's in fourth slide, ma'am.
Ma'am, is it visible?
Yes, ma'am. It is visible, ma'am. It's in fourth slide, right?
Now it is visible?
Will you move this, ma'am?
Yeah, yeah. It's in fourth slide. Now I'll move it, just see whether you can see.
Now I couldn't see, ma'am.
You can see,
Shows
right?
your icon only. Yes, ma'am. I think there is some audio lagging, ma'am. Once I complete it,
Can you
after
see?
that only you get my command.
Okay, okay. Shall I start?
Yes, ma'am. It's in fourth slide, right?
Oh, I think some network issue. Now it's, yeah, it's in fourth slide.
Okay.
Shall I
Yeah, ma'am. Sure, ma'am.
start?
Yes,
Ma'am,
ma'am.
shall I
Start,
start?
ma'am, please.
Yeah,
Yes, ma'am. Please
yeah.
start.
Thank you, ma'am. Yeah.
Thank you.
So yes, I'm starting. So I was talking about your renewable and non-renewable energy sources, and it is very important. I feel my voice is audible.
Yes, ma'am. Yours is audible, ma'am.
My voice. Yeah, yeah. Thank you, ma'am. All that processes were only there. So you can see that diagrammatic view. Also, you can see the coal. So we do coal burning, and then we produce power from that. All that. So we do coal burning, and then we produce power from that. All that energy. It has become origin of this source has become irreversible. Source of energy depletion is irreversible. It was also not eco-friendly. Why it is not eco-friendly? Because were maximum. So the result of which it went temperature of the globe itself. So world level global warming or we went for search of an alternate source of energy. With that search, we found the renewable energy source. And because of that, we stepped into search of an alternate source, and that has got the renewable into picture. I hope now the slide movement you can see that. Yes. Is the slide movement visible? Ma'am, can you see the slide movement? Ma'am, what is the current slide you can see? I sources of renewable energy. Can you see now? I think lately it is moving for you. Sources of renewable energy. Can you see that? For me, it is moving, and it is also showing sharing.
Ma'am, good morning. If you share entire screen, we can get the all information.
Ma'am, now can you is my voice audible?
If you present entire screen only, you can make it visible to all, ma'am. I think you present a particular document.
Now can you see the slide? It's in sources of renewable energy. Now is it okay? No, but your voice is very feeble. Now is it okay? Okay, okay.
The entire screen of your desktop, ma'am.
Now I have presented put slideshow.
Entire screen only is visible to all.
I have put slideshow. I have shared my screen. And now is it visible? Your voice is very feeble, ma'am. 1 second, just wait, ma'am. How can you see now?
I think you
I feel I'm audible now.
Yes, ma'am. You are audible. You are audible, ma'am. But it's
Am I audible? I hope I'm audible.
You are audible.
Now is it okay?
Yes, ma'am. Yes, ma'am.
Still it is echoing.
Yes, ma'am.
So these are the different sources of renewable energy we have. As you all know, like the primary is, and in that our nation is building in wind energy, and followed by that we have solar energy. Then we deal with hydro energy, small hydropower stations. These are the three major things what we have in our nation. Rest all it is in all the abroad countries, the European nations, they are concentrating on it. We do concentrate, but much energy is not produced as we go for geothermal and all. Geothermal, it is very popular in abroad countries rather than India. We majorly concentrate on wind energy first, then on solar, then on small hydropower stations. So different sources of renewable energy. We have solar energy, wind energy, geothermal energy, then we have hydropower, ocean energy, and bioenergy. Bioenergy is none other than the biomass. So as we all know, solar energy is none other than from the sunlight, So from the light energy and the heat energy, we are able to produce electricity. And wind energy, with the kinetic energy from the wind, we can harness electrical energy. We can produce electrical energy, as you all know that. And the solar power produces your DC source, DC power, and wind energy produces AC power. And geothermal, again from the heat, the Earth's crust area, internal heat from the Earth's crust area, you are able to produce electricity. Hydro from water and ocean also from water. Both you're able to get more energy, and the tidal energy what we have. Tide. So from the sea tides also we are able to produce power. And the biomass, so the bioenergy, uh, so much of from the waste we are able to produce electricity. We have food waste, so doing some lot of processes from that we are able to harness energy. So that is your bioenergy. Again, the fuel cell also plays a very important role nowadays. Fuel cell also produces DC power from which you're able to get a lot of important uh, other, that is electricity, that is DC electricity from the fuel sources. So these are all the sources of renewable energy what we have. And now, very important part, this is our prime part. The prime part is why we have to go for renewable energy. Now we've got an idea like why we have to go for renewable energy. The main thing is your reduce your carbon emission. The amount of carbon emissions produced from renewable energy sources are very low compared to non-renewable energy sources. So the prime part is your prime part of our seminar is like why we have to go for power electronics and why power electronics for renewable energy systems. It is very important now. The semiconductor industry is moving out in a very good way. So the top sector in 2023, again we can say semiconductor industry. And over the last few years, we can see that a lot of developments in the power semiconductor devices, high power devices. So semiconductor devices, when we deal with all your silicon or germanium based devices. We all know that. So when we talk about switching devices, we talk about your diode, we talk about your BJT, we talk about your MOSFET. So we have high power rating, again IGBT, those are all the switching elements. And we talk about all these high power rating devices also. And so many innovations has been made in this. So semiconductor industry, it is not only booming out, but at the same time, we have a lot of developments coming out, and the power semiconductor devices have come out in a very good way, and more innovations have started playing a major role in all these devices. So taking all this into picture, we have gone for power electronics. So you can see this here. So you can see an example of a HVDC transmission line and all the fax devices which is used in your power transmission system. So here itself in your HVDC transmission system, we can see a bridge circuit. A bridge circuit, for example, we have your AC. We have your three-phase AC. Again, you can go for a three-phase bridge rectifier, which converts AC to DC. Again, that DC can be converted into again AC, and that can be going to the grid line also. So this is again taken from the grid. Again, it is converted to DC, and it can be fed to DC loads. Further, it can be converted into AC. Again, it can be given to AC loads also. So in these way, the power components play a very, very vital role. That is why they've started interfacing power electronic equipment with the renewable energy sources. So the same thing, why again we have to go for power electronics. The semiconductor based power conversions is very, very important, because when we concentrate on renewable energy source, let us take solar, or let us take wind, or let us take fuel cell, or let us take biomass, whatever it is. So each one produces its power. For example, if you take a solar energy source, it can produce a DC power, but the DC power produced will be an oscillating power, because the solar radiation or the intensity of radiation or the sunlight it varies. So one of the evening it is very radiation. So the power produced also varies only with respect to that intensity of radiation. So that is an important point of view. But we want a constant that constant DC power will be by interfacing a power electronic equipment with the solar. So that is very, very important. So that is why we go for power electronics. That is why power electronics also play a very vital role. And the power electronic technologies is used in all renewable energies. Let it be a biomass, electricity of hydro, solar, any power, without electronic interface, we cannot harness the exact AC power or the DC power from the renewable sources. Ma'am, can you hear me? Now is my voice clear? Now, okay, yes. The echo is there?
No, ma'am. Now it's clear, ma'am.
Okay. All this time it was a big echo for you. Were you able to listen to?
Now your voice is audible and clear, ma'am.
Okay.
No echo, ma'am.
Okay. I just changed my place and
Okay. Okay, ma'am.
okay.
Thank you, ma'am.
Yes. I hope I can start with. All this time I've been discussing
Sure,
about
ma'am.
the various sources of renewable energy. My slide is moving, right? My slide is moving, right? Yeah. Thank you. So I was telling about why we have to go for power electronics, because without a power electronic interface, a renewable energy source cannot produce its effective DC power or AC power. That is very, very important. That's what I was telling an example, like if you are producing a solar power, solar in the sense like the sunlight energy is being converted into DC electricity. That DC electricity may be a varying electricity. You cannot feed a DC load. Why? Because it is because of the intensity of radiation, that is varying intensity of radiation. Because sun's energy, morning it will be morning to afternoon, somewhat it will be bright, again over the night, over the evening it will get faded. So the amount of power produced from the DC source, from the sunlight source, is also very low, or it becomes feeble. That we all know that. So in order to produce a constant DC electricity or DC power, we have to definitely go for a power electronic interface. That is why the power electronics for renewable energy systems play a very, very, very vital role. So that is what I was discussing. And I've shown some examples of your HVDC transmission and fax devices and all. Here you can see a HVDC transmission line. If you see that, you have your three-phase AC. Again, this three-phase AC, if you see here, so this is your, I think I can point and show you. So this is your three-phase AC. Again, that is being given to a three-phase bridge rectifier, which converts that into DC. Again, that DC can be further converted into your AC, and it can be supplied to the grid also. So this is how the power electronic equipment, you can see a diode bridge rectifier here. In the same way, we can go for a thyristor bridge rectifier. So all the semiconductor devices play a very, very important role. So the power electronics is built only with the semiconductor devices. So in the same way, you can see the fax devices also. So these are some of the examples which you can bring in your power electronic interface for renewable energy sectors. So that is very important. Now, the same thing again, whatever I told you now, why we have to go for power electronics, I explained you. So not only for the solar power, for the wind power, for the geothermal power, to produce power from all these sources, we have to definitely go for a power electronic interface. That is what it is being given here. So you can see a simple block diagram representation for your energy power conservation and the process of renewable and distributed energy systems also. Whatever I explained to you, the same thing again, it is represented as a block here. So you can see on the top, you have your energy sources. You have your energy sources. So this is your energy source. Again, energy conversion, we have the source. Then we have to definitely convert that into useful power. So energy conversion. After you convert into useful power, you have to store it. That is what represented as storage and electrical storage. If it's a DC power or an AC power, we call that as an electrical storage. And finally, utility to the loads it has to be given. That is what it is being given. So the source is utilized, it is converted into power, useful power, then it is stored, and then it is being used for future purpose also. This is for general energy resources. So here they have concentrated on two things. One is the non-renewable from the fossil fuel, how you're producing your natural gas, diesel, and how the internal combustion engine functions with this fuel. All that it is being given, and the mechanical movement using a flywheel. Okay, and here the mechanical energy is given to a generator. It is being converted into electrical energy. So this is also possible. This is also possible. That is what it is being given here. Okay, and here down, if you see here again, they have concentrated on the solar. Solar is your photovoltaic system. You all know that. And I told you, like, solar can be classified as your solar photovoltaic system. At the same time, it can be classified as solar thermal system also. It can be called as a solar thermal system also. That is very, very important. So, so you have your solar photovoltaic system as well as solar thermal. So thermal system and your that is your photovoltaic system. So two important types of systems are there: photovoltaic as well as, so solar is classified as photovoltaic as well as your solar thermal system. That is important. Okay, ultimately, so the DC power produced, solar photovoltaic system, from the name itself, here you have your light energy, it is being converted into DC power. So that DC power is being stored in your battery. That's why it is being battery ultra capacitors, which stores high amount of DC energy. Okay, so this can be again, this DC can be utilized again. How this DC can be utilized again effectively by the utility equipment is the energy by using a power electronic interface. This is actually by using a power electronic interface. For example, this is your DC power. You want to again get, for example, I want to have, I'm having a 12 volts DC which is stored in a battery. I want to produce a 24 volts DC here. This power electronic equipment plays a vital role. It is none other than, you can make use of a boost converter. You can use a boost converter. So what do a boost converter do? So it is again a DC-DC converter. So a DC-DC converter, this will convert 12 volts into 24 volts. So that is why they've interfaced this power electronics. So this plays a very, very, very vital role. So in the same way, again, you have your hydrogen supply I've shown here. Hydrogen, when you produce hydrogen, again, you're storing that in your hydrogen tank. It can be used as a fuel for fuel cell. So fuel cell, the input is actually hydrogen. You all know that. So fuel cell, it is similar to a battery. The only difference in a fuel cell and a battery is both are electrochemical cells. The battery can store energy, but the fuel cell cannot store energy. Battery can store DC power, but fuel cell cannot store DC power. By using this hydrogen and doing an electrochemical reaction, the chemical reaction, electricity, DC electricity is produced from fuel cell. Again, this is also stored in a battery, and it can be converted into a useful DC for the utility equipment by means of a power electronic interface. That is what the power electronics is being given here. This is one important. So that's what it is being given. Even the natural gas, again, the byproduct. So it can process a fuel, that fuel. So it produces hydrogen, means that hydrogen can be used for fuel cell. So even from the non-renewable energy sources, you are able to produce a fuel, a byproduct fuel is produced that can be used for energy. So we are able to produce a byproduct non-renewable energy source, and that can be used for the renewable sector also. Is what it is being given here. So the same thing, the windmill. Windmill, again, power is going to be your AC power. That AC power is being converted into DC using a rectifier. Again, that provides a DC. This DC energy can also be stored into a battery. And as I said, the required DC can be produced. This DC power, directly it can be fed to the load. But from this DC input, you can, using a power electronic interface, you can exactly feed utility equipment. So this is what the energy power conservation and how the process of renewable energy power production and the distribution take place. So this diagram is shown. So this is an important diagrammatic view. So next part, these are the polychronic converters for renewable energy system. Now I was telling, like, when you have a solar power, when you have a wind power, when you have a geothermal power or a hydro power, whatever it is, the produced power cannot be fed directly to the load. So please be very clear, like, the produced power cannot be directly fed to the load. It has to be carried to the load only by means of power electronic interface. That is why this seminar topic plays a vital role, that power electronics for renewable energy systems. So without a power electronic interface, it cannot be fed to. So whatever I showed in the previous slide, the same thing, it has been explained here. Here you can see that this is a wind turbine. Yes. So the wind speed, wind velocity, the blade rotates and it produces a final output as AC power. That is what it is being given here. So it generates a AC. AC is being converted to DC using a rectifier. And this is your DC bus line, which carries your DC power. Yes. Again, this DC can be converted into AC and it can be used for AC loads, or directly this DC can be given to the DC loads also. Here it has been shown for the grid line or the AC loads. That is why they're converting the DC into AC and then they're giving into AC load. So here comes again power electronics here, AC to DC conversion, which makes use of a rectifier, and DC to AC conversion, which makes use of an inverter. So all these rectifier circuits and the inverter circuits, rectifier circuits and the inverter circuits are producing your rectifier as well as inverter are producing the rectified DC and the inverted AC are making use of power electronic components. They're all making use of power electronic components. That is very, very important. That is very, very important. In the same way, solar produces DC. DC is again being converted to DC. So here they make use of a DC-DC converter. Some of the DC-DC converters, you all know that buck converter, boost converter, buck boost converter, cuck converter, SEPIC converter, flyback converter, forward converter. So many converters are there. We can call this isolated and non-isolated converters. We generally classify those converters as isolated and non-isolated converters. So those DC converters, it can be fed to DC load. That is what it is being. It is what is being shown. Example like fan, cell phone, all that. So those DC loads can be fed. And here, even for the AC loads, they have shown some laptop, TVs, all that it is being shown. Again, fuel cell is also now, this is also playing a vital role in your renewable sources. They have added lastly as your fuel cell, along with ocean, geothermal, tidal, everything. They have added this also as a renewable energy source. This also produces a DC power. Again, you can convert that into DC again, as it is shown, DC to DC conversion. And finally, and here they have shown some bidirectional DC-DC converter. It is nothing but from source to load, again load to source, you can make use of it. That is your bidirectional DC-DC converter. And so this DC output which is produced, so it can be used for your DC charging station, because electric vehicle now again a hot area in your sector, in your electrical area. Electric vehicle which makes use of your battery. So a lot of electric vehicles are coming out now because of the fuel cost. We are not able to bear the fuel cost, and we're also importing the fuel from abroad, and it is also getting depleted. The sources are also getting depleted. To overcome all that, so our government has started launching electric vehicle, and for that they're building a lot of charging stations. Now electric vehicle have come into picture. All the companies have started producing electric vehicle. Not only that, and charging stations are, again, it is a challenging issue for everyone to build a charging station, and all have started that also, because it is a DC charging station. So from the grid, it has to be rectified, and the respective DC should be given. Maybe a 24 volts DC or a 48 volts DC based on the vehicle, we have to give it. So not only that, you're able to charge the supercapacitor, and you can store that DC energy in using battery also. That is what it is being given here. So they've taken three important sources, and how the power electronic interface with these sources, it is being shown very clearly. Now, what is the role of power electronics in renewable energy systems? Again, so some examples I've taken. The same thing like what and all we saw in the block diagram representation, it is being simply given in terms of each and every source. The first one, the wind energy. So wind energy, AC power. Here, it is very important the wind turbine mechanical movement. So the mechanical energy is given here, and that is being converted into electrical energy by using an electrical generator. We all know that. And this is for a variable speed operation. So when the speed varies, so it is a variable speed wind turbine. So we have a fixed speed as well as variable speed wind turbine. So this is for variable speed. Here, one important thing to be noted: before the power electronic interface, it is your unconditioned electric power. But after the power electronic interface, it is going to be called as a conditioned electric power. Why? Because the power quality issues are sorted out here. So the quality of power, that is your voltage, current, all that has to be taken into consideration. It is not only that, we have to check for the match and frequency, we have to check for the active and reactive power control, everything has to be verified. That is why without this power electronic interface, when you feed to the grid, we have to check for there may be a frequency mismatch also, you cannot feed it to the grid line. So all that is sorted out here. So they make a frequency match. So grid frequency and the produced power frequency should match. That is very, very important here. For that, we make use of a power electronic interface here. So that's why they've given the word voltage, frequency, all the electrical parameter, and the active and reactive power control. So all this is taken care, all the power quality terms are taken into control before it is being fed to the grid line. So that much advantage renewable energy system, power electronics has got in your renewable energy systems. So an example, a diagrammatic view is also represented here. It is your wind energy system with power electronic interface. So this is shown for limited range. So only for specific range speed it is working, and it is your variable wind energy conversion system, and this is your fully variable. So there is no limited range here. You can see here the stator which is being coupled to the grid line and which is coupled to your power electronic interface here. So the produced AC is again converted to DC. Again, you have a DC link capacitor here, which captures the DC, and DC input is given again to a base bridge circuit. So this is again fed to the grid line. So this is what is happening in case of and for variable speed, we have your gearbox mechanism available here. So this is for your limited range variable wind energy conversion system. Here for fully variable wind energy conversion system, here you can see that as usual, the generated power which is converted to your AC, DC, that is your rectifier, three-phase rectifier, again DC clamped, again it is being given to an inverter, and finally fed to the grid line. Here you can have your separate mechanism of power which is fed to the grid and to the power electronic interface, how it is connected. So that is what we see in case of your wind energy system with power electronic interface. And again, one example. So first example we saw with respect to your wind energy and solar power. Now, with respect to fuel cell. So when I say fuel cell stack is nothing but a series of cells arranged together. So each cell is going to produce some, for example, it is producing 2 volts, 5 cells together we can connect, so that it produces some 10 volts. If you connect 6 cells, it is going to produce some 12 volts. So that is what your fuel cell stack. And the fuel cell output is going to be here, it is going to be again 12 volts, for example. So this 12 volts DC, it is given to an inverter. So DC is being converted to AC, and this AC again can be converted to AC also. Again, so why AC again to AC is nothing but it may be a step up or step down. So if you want to step up your AC or step down your AC, so this is one important feature what you have got. So this is your fuel cell stack and DC AC inversion. So these are all the examples we have seen with respect to role of electronics. Actually, I think I wanted to show some examples in MATLAB also, how it is working. Is time there? Am I audible? I hope I'm audible.
Yes, ma'am, you are audible, ma'am.
Yeah. Time there because it will take some time, but your time is only till 11:15. Anyway, after that, I'll ask for queries. Then, if
No
time is there,
problem, ma'am.
okay, fine. Yes. So, this is regarding your fuel cell, and here the same thing. If fuel cell output produces DC, here you can see one example. It is your energy conversion system with DC-DC converter followed by three-phase VSI. So anything, whatever it is, one thing you have to find from all these circuits. Let it be an AC power or a DC power. It can be converted to DC again back to AC. Again, if it is a DC power, it can be converted to AC, and even that AC can be stepped up or stepped down. So there's one more circuit shown here. Like you can see the DC power which is being produced here. So you can see the DC power. So if I say this is my fuel cell power, this is my fuel cell power, or a solar power if it's a PV power, so all these are going to produce your DC powers. So if this DC input is being given, and to have a steady flow of current, you have an inductor at the input side. This DC can be again converted to AC. This DC can be converted into AC by using a power electronic equipment here. So the produced power, again, it can be stepped out using this AC can be stepped up or stepped down by means of using a transformer here, like down by with respect to the turns ratio maintained, that value can also be varied. And this AC is being further given to a bridge rectifier, where AC is being converted to DC. This is again a power electronic equipment. So this is also a power electronic interface. And this DC is again clamped here by using a DC clamp capacitor. A DC clamp capacitor is present. This high voltage DC. So this we can call it as a, since it is clamping the DC, this DC bus line, it can be given to an inverter here. So this is again a power electronic interface, and it can be fed to the grid line. So this can be again fed to the grid line. So you can see how many power electronic stages here you have: P1, P2, again P3. So with which you are able to produce a very good power electronic interface for your circuits, for your the required AC power can be produced by using these kind of power electronic interfaces. That is why the power electronics for renewable energy sector play a very, very, very vital role. So this is what they mean to say. Like without the power electronic interface, without developing a power electronic interface, effective DC power or AC power cannot be fed to the utility equipment, let it be an AC load or a DC load. So this is what the importance of power electronic components, which gives a very vital role for renewable energy sectors. I hope like I'm clear with the explanations. Can I show some examples of MATLAB? Maybe hardly 5 or 10 minutes. Any doubts or queries from this part, from the theory part? I have given a brief overview or an insight into the usage of power electronic equipments with renewable energy source. This is what a complete focus. Any questions from your side? As usual for the PV, it is being shown, that's all. PV produces DC power, the same thing. Same thing is being shown here. How a PV produces a DC power, again a DC-DC converter, the required DC can be produced, and that DC can be converted into AC, you're feeding it to the grid line. So ultimately, without the use of power electronic equipment, the AC power or DC power cannot be produced. That is the ultimate part. So based on the requirement, we have to convert that either to DC or to AC. That is what it is being provided. That is why the power electronic interface play a very, very, very vital role. So this is what is the overview of power electronic sector for renewable energy systems. Any questions from your side? If you have any queries, you can ask me.
Students, if you have any queries, please ask.
See, very simple, very, very simple. What is the effect of power electronics with renewable energy sector? That you have to definitely know. So for that, what are the different sources of renewable energy? You know, that you have to be strong. And what is its functioning? What is the power produced from it? What is it, whether it is a DC power or AC power? And followed by that, what do you mean by power electronics? Why we go for semiconductor devices, high power rating semiconductor devices, and what is the use of power electronic interface with renewable energy sector? That is what you have to know. That is what I explained, and I gave you an insight into it. I gave you a complete overview or an idea about the usage of power electronic interfaces with renewable energy sector. None other than. Any
Thank you,
doubts or
ma'am.
queries?
Really, it was very nice presentation, ma'am. Definitely, students have get some knowledge on it. Thank you, ma'am.
Thank you.
Students,
Any questions?
if you have any queries, please ask.